Okay, so imagine this for a moment. You wake up one normal morning, you check your phone, your bank app works, your passwords still unlock everything, your messages are encrypted, your world feels stable, but somewhere on Earth, inside a room colder than outer space, a machine is processing reality in a completely different way than any computer before it. And if it succeeds, it could transform medicine, finance, artificial intelligence, cybersecurity, and the balance of global power itself. This is not science fiction. This is not someday. It is happening now. Today, I'm going to show you 10 things you need to know about quantum computing and why it affects you far more than most people realize. Because while most people scroll past the topic thinking it's too complex, the biggest companies and governments on Earth are investing billions into it right now. Stay until number one, because that is where it becomes personal. And if you enjoy real technology, hidden shifts, and the future explained clearly, subscribe now because this channel is only getting started. Number 10. What a qubit really is and why it changes everything. Every device you use today runs on bits. A bit is simple 0 or 1, off or on. Your laptop, your phone, giant data centers, satellites, trading systems, all of it reduces to billions of tiny decisions made using zeros and ones. Quantum computing uses something else, a qubit. And unlike a normal bit, a qubit can be 0, 1, or both at the same time. That sounds impossible because everyday objects don't behave like this, but particles do. This property is called superposition, and it means a quantum computer can represent many possible states simultaneously instead of testing them one by one. Think of a maze. A classical computer often checks path after path. A quantum system can explore many paths at once. That doesn't automatically solve every problem faster, but for the right kinds of problems, it changes the scale of what's possible. But there's a catch. Qubits are fragile. Heat, vibration, stray radiation, electrical noise, even tiny disturbances can collapse their quantum state. That means building a useful quantum computer is like trying to balance a soap bubble during an earthquake. And yet, companies are doing it right now. Number 9. Entanglement, the phenomenon Einstein hated. Even Einstein was disturbed by this one. He called it spooky action at a distance. Quantum entanglement happens when two particles become linked so that measuring one instantly relates to the other. Even when separated, no wire, no visible signal, no classical explanation. If one changes, the system responds as one connected whole. Why does this matter? Because entanglement allows qubits to coordinate in ways classical systems cannot. That coordination is where much of quantum power comes from. The more stable entangled qubits you control, the more complex the system becomes. But here's the hard part. Keeping many qubits entangled long enough to do useful work is one of the most difficult engineering challenges on Earth. Tiny errors multiply fast. That's why, for years, critics said practical quantum machines were decades away. Now, many researchers believe the timeline is accelerating, which is why the next section matters. Number 8. Google, IBM, Microsoft. The race already happening. This is not theoretical competition. It is active. Google revealed major progress with quantum chips designed to reduce error rates while scaling qubit counts. IBM has published roadmaps toward larger modular systems and commercial quantum services. Microsoft has pursued topological approaches aimed at building more stable qubits from the ground up. Three of the most powerful tech companies in history are pursuing different paths to the same destination. Ask yourself, when giants spend years and billions chasing the same technology, what do they see coming? They see leverage. The first systems that solve commercially valuable problems could create enormous advantages in pharmaceuticals, logistics, finance, defense, and AI. And unlike social media trends, These companies do not invest at this scale for hype alone. They invest when they believe a breakthrough can reshape industries. Number 7. Why nations are spending billions. Once governments enter the race, the stakes change. Quantum computing is no longer just science, it becomes strategy. Countries around the world have announced national quantum programs worth billions combined. Why? Because whoever leads in quantum technologies could gain advantages in secure communications, materials science, economic competitiveness, defense systems, intelligence capabilities, advanced simulation. This is similar to the space race, but quieter. No rockets launching on live television, no cheering crowds, just labs, patents, talent wars, and long term positioning. And history shows something important. When strategic technologies emerge, the nations that move early usually shape the rules later. Quantum may become one of those technologies. Number 6. New medicines that classical computers struggle to design. This is where quantum stops being abstract. Molecules are quantum systems. Atoms interact through probabilities, energy states, and behaviors that become incredibly hard to simulate on classical machines. That matters because medicine depends on molecules. To create a drug, researchers need to understand how compounds bind, react, fold, and behave. Classical computers often rely on approximations because exact simulation becomes too expensive. Quantum systems may model some chemical interactions more naturally. That could accelerate drug discovery, protein modeling, new antibiotics, targeted therapies, material design for medical devices. Imagine treatments for diseases that remain unsolved today, arriving faster because we finally had tools able to model nature more accurately. That is why pharmaceutical companies are watching closely. Number 5. Solving optimization problems worth billions. Some of the most valuable problems on Earth are not about graphics or gaming. They are about optimization. Examples. What is the best route for 10,000 delivery trucks? How should an airline schedule crews and aircraft? How should a power grid distribute energy efficiently? How should supply chains respond to disruption instantly? These problems explode in complexity as variables increase. Classical systems often settle for good enough. Quantum approaches may help search vast solution spaces more efficiently for certain cases. That means lower costs, faster logistics, less waste, better resource allocation, competitive advantage. And if one company saves even 2% globally at scale, that can mean billions. Sometimes the future is not dramatic. Sometimes it is simply more efficient, and that changes the world anyway. Number 4. Climate, batteries, and future energy. This part gets ignored far too often. Energy systems depend on materials. Better batteries need better chemistry. Cleaner industry needs better catalysts. Grid efficiency needs better modeling. Some of these challenges involve quantum level interactions, too complex for easy classical simulation. If quantum tools help design longer lasting batteries, better solar materials, carbon capture catalysts, superconducting materials, cleaner industrial processes, then their impact goes far beyond computing. It affects transportation, climate goals, manufacturing, and energy independence. In other words, quantum computing might help power a greener future not by replacing energy, but by discovering better ways to store and use it. Number 3. The threat few people understand. Q Day. Now we reach the uncomfortable part. Much of modern security depends on encryption. Banking, governments, private communication, digital identity. Many current systems rely on mathematical problems that are extremely hard for classical computers. But some of those systems could become vulnerable to sufficiently advanced quantum machines using algorithms like Shor's algorithm. The day that becomes practical has a nickname: Q Day. The moment quantum machines can break major current cryptographic systems at useful scale. Will it happen tomorrow? Probably not. Will it happen eventually if progress continues? That is why security agencies take it seriously. And here's the deeper concern: encrypted data stolen today could be stored and decrypted later. That means future quantum capability creates present day risk, which is why governments and standards bodies are already pushing post quantum cryptography, new encryption designed to resist quantum attacks. The transition could take years, and the world has already begun. Number 2. Quantum AI. When two revolutions collide, artificial intelligence already changed the world. But training powerful AI models requires immense computing power, time, and electricity. Researchers are exploring whether quantum systems could accelerate certain machine learning tasks, optimization steps, or data structures. This does not mean magical instant AI, but it may mean hybrid systems where classical AI and quantum processors work together. Imagine faster model training for some workloads, better optimization, improved scientific AI models, new ways to analyze complex data. And notice something important: the same companies leading AI are also investing in quantum. That overlap is not random. They are preparing for a world where the two fields reinforce each other. If AI defined the last few years, quantum enhanced AI could help define the next era. Number 1. What this means for you right now: you do not need to be a physicist. You do not need to work in tech. You are already connected to this story because quantum progress touches four parts of ordinary life. First, security. Your accounts, payments, identity, and privacy depend on systems now being upgraded for a quantum future. Second, medicine faster. Molecular discovery could mean treatments that do not exist today. Third, jobs and industries. Finance, logistics, chemistry, automotive, defense, AI, cybersecurity. These sectors may shift first. Fourth, opportunity. Every major technological transition rewards people who understood it early, not experts, early learners. And this is the moment quantum computing still feels confusing enough that most people ignore it. Historically, those are the moments that matter most, because by the time everyone understands something, the biggest moves are usually already over. Quantum computing is not magic. It is not guaranteed. It is not finished, but it has already crossed an invisible line. It is no longer a curiosity. It is now a global race involving governments, trillion-dollar companies, top scientists, and the future of digital power. And every time humanity builds a new tool to understand reality, reality turns out to be stranger than we imagined. So the real question is not whether quantum computing matters. The real question is who will be ready when it does. And remember, the universe doesn't reveal its secrets to those who rush. It reveals them to those who know how to look. Subscribe and keep listening to the silence.